So I tell you first of all, how do we write the sample space for tossing a coin? I will tell you. See, this is something which books do not tell, but I will tell you. If you toss a coin, you can have head or tail. Agreed? Either head or tail. So see, what you can have, head or tail. Agreed?
Yeah.
When you do it once, when you do it another time, so you can have head, 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 tail, tail, head, tail, tail. Okay. Now what you do? In order to write all these things, you will just do carbon copy of this HT. Here you will write H and T when you are doing. For first two you will write HH, and for second half you will write TT. Now, are you getting something? HHTH Got it? When you are tossing coin two times. Okay? When you are tossing coin three times, you can have TTT, HHH, HTH, THH, THT. Got it? Now, I'm using a different color. Now, what you do? So first you wrote HT, then you put a carbon copy of HT and HT, and for first two you wrote HH, then for second two you wrote TT. Okay, my dear friend. Now, what you are going to do? You are going to write HH, TH, HT, TT. See, exactly same thing I wrote. Now, because I am tossing for the third time, okay, I am telling you how to write. I am telling you just a way of writing the possible outcomes. Okay, for first, for top half, I will write H. For bottom half, I will write T. H, 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 T, 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 T. Now, do you get it? How I am writing so that I am not missing any sample space? Got it?
Yeah.
So this is called sample space basically. This is called sample space. I can, for you, I can write properly. If I have to write now, this is the way we write. This is a sample space. My dear friends, sample space, I did not buy S. I can write like this. I mean, what are the possible outcomes? They are called sample space. T, T, H, 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 T, H, T, H, T, 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 H, 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 T. Many of the times we get confused and we write the same thing. We write the same thing. But this is one of the best ways I have found that in this way we can write the sample space without getting confused. Okay? This is a sample space, my dear friend. Now, you have understood what is chance process. Tossing of a coin is a chance process. Okay? My dear friend, tossing of a coin is a chance process. Sample space is outcomes. Okay? So I write it down. This is a chance process. So the possible outcomes are here. I have written all the possible outcomes.
Yeah.
Hmm? Now you have got the possible outcomes, Gunjan. Now we will define a variable. Okay, we will define a variable. What is that variable? I am interested in defining a variable. What is that? Let X represent the number of heads obtained.
X represents the number of what?
Number of head obtained.
Head.
Yes, I'm writing, don't worry. X represent the number of heads obtained. Okay.
Okay.
My dear friend. So X can have how many? X will take some numerical value.
Yeah.
X will take some numerical value.
Yeah.
So random variable takes numerical values. Okay, random variable. Out we define sample space. Sample space is sample space. Basically, it's a possible outcomes. Okay, possible outcomes we deal with. When we deal with our possible outcomes, after that, what will happen? We will define a variable. Number of heads in the number of heads. This is what we defined as our variable. It will have some numerical value. We are going to have some numerical value for that one. And this is the significance basically. This is basically the significance of random variable, that they obtain a numerical value. They obtain a numerical value. It's not that uh, they will also be in the form of HHT or THH. No, they will have some value. Now I will tell how. My dear friends, see that X represent what I have seen. That X represent the number of heads obtained. Okay, so we can have, so Gunjan, we can have X equal to 0. We can have X equal to 0.
Yeah.
Okay, X equal to 0 when there is TTT. Okay, X equal to 0 when there is TTT. Correct. X equal to 1 we can have
H
when
HTT TXT.
yes, X equal to 1 when number of heads, one H. So TTH, 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 THT,
Yeah.
HTT. Okay,
Hmm.
fine. Next, X equal to 2. X equal to 2. X equals to 2. For X equal to 2, we have
HHT HTH
HHT
HTH and THH.
and THH. Okay, my dear. X equal to 3.
HHH.
Triple H. Okay. So this is what X can take. X is taking some numerical value, represent the number of heads obtained. Number of heads obtained. If an X is 0, what is the which data to choose? When X equal to 1, what on out of the sample space, what are my favorable outcomes? X equal to 2, what are my favorable outcomes? So these are now my favorable outcomes. Out of total outcomes, these are my favorable outcomes.
Right.
Got it? Now, what I'm going to do, I'm going to make probability distribution of X. Now, what is this probability distribution of X? See, I mean, you will understand each and everything when I will do things. Don't don't rush into understanding things. What is probability distribution? What is random variable? I have not defined the random variable yet properly. Okay,
Hmm.
you will understand. I mean, first we will do the question. Then you will understand. Oh, this is basically a doing a question, real question before you. I mean, the stats is like that. Only first you do, then you understand what you have done. Probability distribution of X. What is this probability distribution of X? Value and probability. C. My dear friend, Now what I'm going to do is value C. So what are the values which x is taking? Value of what? Value of x basically. Value of x. X is taking 0,
Yeah.
x is taking 1, x is taking 2, and x is taking 3. Okay? My dear friend, when x is taking 0, what is the probability of x taking 0?
1.
No, 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 no. This is TTT. How many possible outcomes are there? 8 are possible outcomes. What is the favorable outcome? TTT.
Yeah.
Okay? 1 out of 8. Got it?
Okay.
This is what I wanted to tell you.
3 out of 8 and then 3 out of 8.
Perfect, perfect, perfect. 3 out of 8. So these are these are the probabilities which we are writing.
Right.
Possible out of total. Okay? And this is 1 out of 8. Got it? So for 0, what is the probability? I mean, what is the probability that x is equal to 0?
1 out of 8.
1 out of 8. Like this. Understand it like this. 1 out of 8. 3 out of 8. For 2 also, it is 3 out of 8. For 3, it is 1 out of 8. Okay? This is called probability distribution of x. And x here is a random variable. Got it?
Yeah.
This is how we understand basically a random variable. This here x is a random variable. Now I will tell you this is a random variable. I am writing RV. This is basically for this there is a specific term that's called discrete random variable.
Yeah.
Discrete because it has spaces. We are defining, we are counting it 0, 1, 2, 3. Got it? That's why it is discrete. It is not like continuous. It cannot take infinite value. We will discuss about the difference between discrete and continuous in a while. Don't worry about it. Okay. But just I am giving you a small brief beforehand itself. This is a discrete random variable. My dear friend, can we make a graph for this probability distribution?
Yeah.
Do you know what is called histogram?
Yeah.
My dear friend, here we go. So when we talk about this one, I am making a histogram. Histogram is something like this. See, so here I am going to write values, value which x is taking, value of x, and here I am going to write probabilities. Okay, my dear friend. So what values? See, let's say it is starting at 0. What values x was taking? 0, 1, 2, 3. Histogram. In histogram, the bars are just side by side. There is no gap between them.
Yeah.
Do you know this one?
Yeah.
You must have studied in your previous classes. So I'm writing this is 1 by 8, this is 2 by 8 probability, and this is 3 by 8 probability.
Yeah.
We can have. My dear friend, here we go. 0, it is 1 by 8. Okay? For 1, it is 3 by 8. For 2, it is 3 by 8. For 3, it is again 1 by 8.
1 by 8.
Are you getting? So this is
Yeah.
basically a graphical representation. This is a histogram showing the priority distribution of random variable x, where x denotes the number of heads obtained. Okay, I have defined I have defined a chance process which was tossing a coin. Then we got some outputs. Then we got some outputs. Those outputs are called, what do you call the outputs? You call the
Uh,
output,
random variable.
no, no. Random variable we define. We the tossing of coin. The tossing of coin. So sample space is something which goes for which tells possible outcomes, my dear friend. After this, think step by step. Whenever you study statistics, or maybe not just statistics, anything when you deal with, obviously try to think everything in terms of steps. If you think in terms of steps, it will be able memorized very easily.
Yeah.
First, we define chart process. Then you got some outputs. We got them sample space. After that, we define random variable. It can be anything. Random variable can be anything, like getting tails, getting heads, whatever you wish to do. Okay, it's up to you. Now you have the data before you. Whatever you want to define, you define it. So number of heads. So number of heads like 0, 1, 2, 3. Okay. If you toss for 4 times, then X can take 4 also. Okay. So X is taking numerical values.
Yeah.
X is called random variable. Can random variable takes numerical value. Okay. Numerical value that describes the output of some. They
Output
are
of
the outputs of some.
chance process.
Yeah, they are the outcomes of some chance process. They are the outcomes. Outcomes like getting 3 heads. H, H, H. It was the outcome of a chance process which was tossing a coin. Are you able to
Yeah.
relate these mathematical terms with the real life thing? See, if you just talk in
Yeah.
terms of mathematics, if you just talk in terms of mathematics, na, you will just you will go confused. You won't understand. You will have to relate with a real life problem. Unless you
Yeah.
do that, you won't be able to do that. Understand?
So,
Now, my
so
dear,
first comes the chance process, then all the possible outcomes in that are sample space, all the outcomes which happen. And if you want to find one particular outcome, we give a numerical value to X,
random variable. Yeah, yeah.
random variable.
We define a random variable.
Yeah, and then
And
after that, we take the random variable and then we give the probability of it, which we make a probability distribution.
yes, correct.